Also, Arat, Narmin, Javid, guys, can you hear me?
Yes.
Yes.
Good. Very good. So, guys, welcome back. Good to see you again. Before we start our class, as you know, we are going to have tests, okay, next Friday. And the test time is 1 hour. And you will have around maybe 15 questions, okay? And you have to solve fast. All questions will be multiple choice questions. And I'm going to prepare all the questions using Google form. And that's it. You have to start at 9 o'clock. And I mean, I don't know in Azerbaijan time, what time is it? But now here it is 9 o'clock and you have to finish at 10 o'clock. Okay. So,
Hello.
hello. Who are you?
Hussein Hajiv.
Hussein Hajiv. Very good. Okay, good. So, Arat and guys, last time I gave you that one sample example. You were supposed to practice those questions. I don't know how much you did it. Okay, now we are going to solve. We are today and next time we are going to do revision. Next Friday you will have test, and after that again we will start new topic. And after next week, for a few weeks, maybe 3 4 weeks, we are going to study trigonometry. Okay, that is our the second stage. There's 3 chapters, and after that, maybe again 2 3 weeks or 4 weeks, we will study geometry, and after that, we will practice only SASMO type questions or different types of questions, and we will see um, until April. That is my plan. After April, we will see. So, grade 9. Okay. So how are we going to solve these questions? Guys, if I ask you to solve this, we may lose a lot of time. Okay. I will just ask your idea because after all, having idea, that is the most important thing. If you have the idea, the rest is not that much complicated. But if you have no idea, it is really hard to try a question because you don't know what to do. You don't understand the problem. Maybe you understand, but you have no idea how to solve this. And how do we have actually ideas quickly? It depends on your knowledge and experience, right? To get the knowledge, you have to study, you have to listen to the teacher, or you have to read a book. And to gain more experience, you have to practice as many problems as possible. I mean, different problems, not the same question, like solving the same quadratic equation again and again and again. It doesn't actually give you anything. At a certain time, that's much is enough. Now you need to solve more questions. Usually in math, what kind of questions are complicated? Number one is tricky questions. Number two is the solution requires a combination of skills. Just using one concept or one topic or one idea, you cannot solve this. You have to use some different ideas. In the first step, one idea, in the second step, another idea, in the third step, another idea, or combination of ideas. Usually, this type of questions are challenging. Okay, so today we are going to solve these questions, SASMO 24, secondary 2. Okay, so after the first, I want you to practice all the questions. I want you means maybe it is not so polite. I suggest you to practice all the questions in secondary 2 and secondary 3. Now in my hand, I have all the questions from 2013 to 2018, but I'm trying to find now the past papers 2019 and 20. If I can find those papers also, I will share with you. Okay, Arat, any questions?
No.
Okay, again. Okay, let's start then. So that is Mathematics Olympiad S2 2014. Let's start with easy questions. The first, actually, the 10 questions are easy, but here the questions are a little bit tricky, and also you need to use a logic, and also you have to solve fast, right? Because time is not a lot. You have 25 questions, and you are given around maybe 2 hours only. So let's start with the first question. The first day of 2014 was a Wednesday. And there are 365 days in 2014. In what day of the week will 2015 begin? And we solve this question. We know that in 1 year, this 365 days means that we can write it as 52 times 7 plus 1, right? In every year, we have 52 weeks and plus one more day. And that is a kind of recursive, right? It's 7 days, 7 days, 7 days, but actually just days shift 1 day. To this year, if the 1st January, right? If it is Friday, next year 1st January will be, it is Saturday. Next year's January will be Saturday, providing that that year does not, actually is not a leap year. If it is leap year, at that time we have to add 2 days, because in leap year we have 366 days. This one is in S2. Maybe in S3 they may ask this question. For example, let's say 2000, what is it? Let's say 23, right? How about in 2025? But between 2023 and 2025, we have 2024, right? That is a leap year. So at that time, actually, you have to consider that leap year. Okay, so the first day of 2014 was a Wednesday. Also, Javid, let me ask this question to you. The first day of 2014 was a Wednesday. So there are 365 days in 2014. In what day of the week will 2015 begin? Javid, what is the answer?
I think on Thursday. On Thursday.
Thursday, right? It is Thursday. Okay. What is the maximum number of parts that can be obtained from cutting a circular cake using 3 straight cuts? Guys, you can just unmute your microphone, answer the question. I give you 1 minute to answer the question. If no answer, then we will discuss together. The question is, we have to divide this into maximum number of pieces, right? So that's why it says that what is the maximum number of
6.
parts that can be obtained from cutting a circular cake using 3 straight cuts? Yes.
I
8,
say
9.
6. 6.
6
Yes.
I say
and
8.
8. 6 is greater than 8. Any bigger number?
9.
Okay. 9. Is 9 possible? How?
I think it's 8 or 9.
Give me one answer.
8.
I think only 8, right? I don't know, guys. Also, I don't have the answers, but I think the answer is 8. Why? Because one, I have to cut from here, right? Another one, I have to cut here. Now we have 4 pieces, right? Javid, how about now if I cut from here through here? We have a knife, right? It's also just one cut. So now our 4 pieces, now they become 8 pieces. Because it says that cutting a circular cake using 3 straight cuts, right? All of these cuts are straight cuts from the top to, right? And after that from the middle. So maximum is, it is 8 pieces. Next question, solve this equation. And I think we have already solved this. If you want, you can try this again. I give you 1 minute, guys. Do it and tell me the answer. Guys, if you need to keep a piece of paper or notebook on your table, as I told you, we are doing revision today. Okay, 1 minute.
Teacher, can I say the answer?
Yes, what is the answer?
6.
6. Okay.
Yeah.
Let's wait for others, Arats. Now we have 50 seconds. After that, we will discuss together. Hussein, any answer? Are you trying?
6. 6.
6. Okay. Any other answers, Javid? Okay. So again, this goes to infinity, right? If it goes to infinity, the whole thing is equal to 3. And also, if I start from here, it is the same thing with the original one. Also, it should be 3. Now, from here, x plus 3 is equal to 3, right? If you square both sides, x plus 3 is equal to 9. So dot, 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 the value of x is equal to 6. Yes, Arat.
Teacher, but there is easier way as well.
Yeah, either way is from here I can just substitute. It's 3, right? 3 plus what number? Square root is equal to 3. That's equal to 6. Is
No,
it this
not
way
like
or
that.
what is it?
It's like this. The number should be multiplied by a number before it. Like if it be 7, 7 times 6. Like 14, 14 times 13. Because when you take it to the root, then when you add it, that one becomes the square root of that one because it's like you multiply it twice. So you have to take one number down and multiply it by itself.
So that method is simpler than this.
Yes, you have to just multiply 2 and 3.
Okay, that's also one step, Arat. It's not so long.
No, I mean like for big numbers.
Ah, okay. Another question. Javid, this question is for you. Find the exact value of 1 minus 0.99999. What is the answer?
Can I?
Yes, Hussein. What is it?
It's 0.
It is 0, right? Because this one 999, it never stops. That's equal to 1. So the answer is 0. Next question. Mersenne primes are prime numbers of the form mp is equal to 2 to the power of p minus 1, where p is a prime. So we call this Mersenne primes. Special, maybe it's given to somebody's name. So for example, 3 is 2 squared minus 1 is a Mersenne prime. Find the fourth largest Mersenne prime.
Teacher, but that's impossible because when you count it, like you can have 9999997. It's still prime.
What do you mean? For example, here with this 3, right? It is 2 squared minus 1. It's a Mersenne prime. Okay, here we have 2 squared minus 1 is equal to 3. 2 cubed minus 1, that's equal to 7. 2 to the power of 4 minus 1, not 4. It is 5, right? That's equal to 31. And that's 2 to the power of 6, not 6, it is 7 minus 1. 2 to the power of 7, that's equal to 128, right?
127.
Minus 1, it is 1 to 7.
Teacher, but it's a fourth largest.
And after that, here we have 11 minus 1. Not 11. No, it's 2.
200, 2055, I think.
Find the fourth largest. The first largest, second largest, third. Okay.
But the largest is infinity. You cannot, if you count. Not infinity, I mean very big number.
Okay. That is a little bit maybe we cannot say the point here. Mersenne primes are prime numbers of the 4. Okay, 127, it is 310, 60. Okay. Where P is a prime, for example, 3 equals, okay, is a Mersenne prime. Find the fourth largest Mersenne prime. If it is the second one, for example, 2 to the power of 13. What is it? Is it
10,000
getting bigger
something.
and bigger?
If you get, you just get an infinity numbers. It's impossible.
But they say force.
Okay.
Largest, not smallest. If it was the smallest, it was 127.
Okay. Now I have no idea. Hussein, any idea? Good. I think we need to study a little bit about this. Also, I say for the first time, this Mersenne prime. I don't know, maybe I saw this before, but here it
Can
says
we?
the largest. Huh?
Can we get help from Google?
Now, let's have a look at other questions, and after that, we will do that. Now, if we do that, we may waste time. Okay?
Can we do it? Because like if I don't answer any question, I will just cannot concentrate. Because now.
Okay, Arad, you do it. Okay?
Okay.
Or we can do this Mersenne prime numbers. All right, for some integer, they are named after Marie and Mersenne, a French man. Okay, therefore, equal definition of the Mersenne of the form for.
I
Okay.
found the largest.
It is 8191.
No, the largest is 82,589,933. Is the largest, not the fourth. Who came up with this idea? And it's to the power of that number. 2 to the power of that number. It's near infinity.
No, okay. No. Here, I don't think they asked that question Arat here. Here, Mersenne prime, find the fourth largest Mersenne prime. It says the fourth largest.
It has to be smallest. Because the smallest it
Yeah,
will be
I think
1.
so. I think so. It must be a mistake here. Okay. There must be a mistake here. Okay. All right. All right. Okay, guys, I will check this. Okay, I have notes. There are some technical mistakes in some questions. I think it should be the smallest because it continues. Maybe we don't know all of them, but the largest one is so huge. It must be because it's S1 or S2. They don't ask that question because even if you sit and try to find this, it takes a lot of time. It should be fourth smallest. Okay, at that time it will be number 2, 3, and 5, and 7. It will be maybe 127, right? Or maybe this 1, 2, 3, 4, right? It should be 127. Okay, all right. I have some notes actually. I have some corrections. I need to have a look at the time. After that, I will let you know. Next question. That's very easy question. Simplify the expression. Let's ask this question to Hussein. Javid, are you there? What is the answer here? Have you ever seen such question before?
No.
It is very easy,
I'm
but a
here.
little bit tricky question. Javid, what do you think? What is the answer?
This one is easy.
I don't know. I don't know.
The equation
Hussein,
look like monster.
I don't know.
you don't know. It's a kind of
Yeah.
puzzle question, actually. It's not that much mathematics. Here we have x minus a, x minus b, x minus c. What are these? A, B, C, the letters in the alphabet, right? And it
Alphabet.
continues
Yes.
until z. And before the somewhere here, what we have here? Also, we have something like this, right? X minus x. So dot, 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 dot. What is x minus
Dot is
x?
0.
That's equal to 0. 0 times anything, that's equal to 0.
I hate this
Uh,
question. What's the point of having a question with 0?
All right, you know, when Einstein was very young, maybe 4 or 5 years old, okay, and they ask, what is this? What is it?
What? B.
It is B, right?
Capital.
letter.
Is it
Capital
letter?
B.
Is it letter B?
Yes. Actually, if you look it from another way, it's like egg. 2 eggs.
Okay, good. But you know what Einstein answered? He said that that is my grandfather's glass, eyeglasses. You know, he just what sees from here is eyeglasses. Okay, I mean that's just a story or a joke. I don't know. That's what I heard. Looking at things from different perspective, right? Looking here, for example, 6, and you are standing here, and I am standing here, right? And for you, the 6 is 9. For me, it is 6. Okay, and that's why also this kind of puzzles. When you just solve this, we have more and more questions. You actually also think that okay, there may be some different way. Okay, that actually teach you how to look at things from different angles. And immediately I will ask you another question, for example, and also you will get you get surprised. Maybe you have seen this before. There's also 1, 1, 11. Have you ever seen this number sequence?
No. But teacher, when you can't solve this one, these things, and when it's easy, you think like sometimes you think that you are stupid because like when you can't understand these easy things, like sometimes.
No, no, here we are talking about variables in algebra, right? For a variable, what symbols do we use? We use letters, right? Letters in the alphabet usually. So actually here, this is just alphabet. Can you just say that A, B, C, D, E, right? And also X is one letter in the alphabet, right? After a certain order, also X comes, and X minus X is equal to 0. So 0 times anything equals 0. There's also a mathematical question here, but it's a little bit tricky question. But there's nothing wrong with this question.
No, I mean like when you can't solve this one, like, and when you see that the solution is so easy, you feel confused.
Okay. How about this question? What do you think? What is the next term here?
I saw this question and I knew the answer, but now I don't know.
Really? Let's see. Hussein,
Yes.
what do you think? What is the next term?
I don't know.
You don't know. Also, are you there?
Yes.
Yes, also. What do you think? Have you ever seen this question before? And also, that's a tricky question, right? Here, if you read this, it is 1. Now, what is it? I just see that actually, I see 1, 1, right? So whatever you pronounce, just write it in the next term. What do we see here? It is 1, 1. Now read the second term. What is it? I see 2 ones. So 2 ones, I just write here 2, 1. And now how do you read this? It is 1, 2, 1, 1. So that is 1, 2, 1, 1. Now if you read this term, I have 1, 1, 1, 2, 2, 1, right? 1, 1, 1, 2, 2, 1. Now if you read this, what do we see here? We have 3 ones and 2 twos and 1 ones. It means that what you are pronouncing, you are just writing in the next term. And you may see that that's a tricky question. That's just mathematical puzzle. Okay. They may also ask this kind of question. Anyway, guys, let's continue. Question 8. That is really interesting question. How many squares are there in a 5 by 5 square grid? Guys, I will give you 2 minutes.
A
Think.
lot.
And okay, a lot, but how many? It is not infinity, right? And tell me the
25.
answer. Or if you have no answer, tell me at least the method. Okay. You have two
I know
minutes.
the method, but it will take time.
No, it doesn't take much time. It takes time, but not a lot of time. I'm just interested in your method. How would you solve this question?
$80?
80.
Yes.
Okay. Let's wait for others. Javed, Hussein, also. Do we have anyone else here? Eldar. Oh, we have Eldar. Narmin. Narmin, you're also here. Narmin, are you calculating?
Yeah,
How many did you count so far?
I still don't know.
Okay. Hussein, how about you?
25.
25.
Did I change it to 55? 50.
Oh, you change your mind. Okay, 55. Okay.
I think 25.
God, let's do them together. Okay. And of course, when I'm doing this, I'm not saying that that's the best method. I don't know. But actually, how would you do this question? In the question, it says that how many squares are there, right? As I see in this grids, if I just take one side of the small square as 1 unit, it is 5 by 5 square, right? So how many square we may have here? We may have here, for example, 1 by 1 squares, right? And we may have 2 by 2 squares, and we may have 3 by 3 squares, and we may have 4 by 4 squares, and we can have 5 by 5 squares. Now, if I just start with the biggest one, how many 5 by 5 squares do we have? We have only one, right? We have only one 5 by 5 square. And how about
Then
4 by 4? As you see, 4 by 4 from here, right? From this point until this point, we have one. And also from this point, if I just continue, I'm just drawing from here, that is one. And that's the first one. Let me just draw like this. And how about if I draw from here, that is the second one, right? Two. And now if I just move down, that is another one, three, right? And this one is another one, this is four. So how many 4 by 4 squares do we have? So here we have four 4 by 4 squares. Now how about 3 by 3? 3 by
9.
3, let me just only one of them. This one is A, let's say this point is B, and this point is C, right? This point is D. That is one. I can move this B to the side. I can have another one. I can move this 1 unit to the right. I can have one. How many? We have 3. In a similar way, if I just move 1 unit down, we have also 3. And 1 unit down, also we have 3. So how many do we have here? Here we have 9 3 by 3 squares. Now here we have 1 squared, right? This one is 1 squared, and this one is 2 squared, and this one is 3 squared. Most probably this 2 by 2, we will have 4 squared, 16. How about 1 by 1? It is 25. So here we have 5 squared one by one squares, and this one is 4 squared. So the total one is, here we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And the square of the numbers, what is it? It is 1,
55.
is it 55? 1,
Yes.
4, it is 5. So 1 plus 4 plus 9 plus 16 plus 25. 25, that is 55. So altogether, we have 55 squares. That is just actually a systematical way of counting squares, right? Okay, another question, question 9. If x and y are positive integers, find the values of x and y which satisfy the equation. Okay, that's also actually, what is it, brainstorming question. So it says that if x and y are positive integers, so that means that here we have x and y, these are positive integers, right? So what is it? Find the values of x and y which satisfy the equation. Yeah, to do this one first, we should write here as x minus 2y times x plus 2y, the product. On the right hand side, 41, right? What is 41? 41 is a prime number. And also, since x and y are integers, right? Positive integers, so that means that this x minus y is always smaller than x plus y. Because if you're talking positive integers, the sum of two positive integers is always greater than the difference of those positive integers. So the only way here is then this x minus 2y, right, should be equal to 1. X plus 2y should be equal to 41, right? And so from here, we should just solve this. If you add them together and divide by 2, it is 21. If x equals 21, y should be equal to 10.
Teacher, but you can also choose 7 and 2.
7 and 2?
49 minus 8 is 41.
You mean 7 and 2?
Yes.
7
7 squared.
squared minus 4 times 2 squared, you mean?
Oh, sorry.
Is 16, right? No, it's not possible because here this x minus y, it is less than x plus 2y, and they are positive. If they don't say positive here, all right, we may have more solutions. But here it is positive. That's why, that's it.
Teacher,
Because if they don't say positive, then x minus 2y, it is minus 1. X plus 2y is minus 41. At the time, we will have more solutions.
teacher, but how you know x minus 2y is equal to 1?
No, because here x and y are integers, right?
Yes.
So if it is integer, if you multiply integer by 2 and subtract this from another integer, also this x minus 2y, it must be integer. X plus 2y, also it must be integer. And here we have 41, it's a prime number, right? So the only way to write this 41 as a product of two integers, that is 1 times 41.
But why we can't write it at decimal?
No, because it says integers, all right, it says integers.
Ah. Oh.
Okay, if you just say, if they say just real numbers, all right,
Oh.
at that time this equation has infinitely many solutions.
Thank you.
Okay, that's why if it's integer, they have only one solution. If it is positive integer, if it is negative integer, at that time a bit more. Question 10. Find the dimensions of all the rectangles with integral size whose area and perimeter are numerically equal. Guys, before I continue, let me just tell you one thing. Okay, usually these kind of questions, you have to practice yourself. You have to solve them. And if you don't understand, you have to bring to the question. But here, I'm just showing you how to practice and solve these questions. And if you want, we can continue solving this one. After this, once again, you have to solve these questions. Actually, this is S2. But next time, after we finish this, we will solve question from S3. Okay. So find the dimensions of all the rectangles. Dimensions means length and width, right? These are, we call them dimensions. If you're talking about a solid, for example, their dimensions are length, width, and the height. But rectangle is two-dimensional figure. That's why it has only length and width. Okay, find the dimensions of all the rectangles with integral sides. Again, what does integral sides? That means that whole numbers. That means that natural numbers. Because when we're just talking about the side, we do not use negative numbers to measure the length of a line segment. That means that we are talking about only maybe 1, 2, 3, 4, 5. So these are whole numbers. I mean, even not whole numbers, I can say natural numbers, because whole number contains zero. Even the side of the rectangle cannot be equal to zero, right? So it should be greater than zero. Anyway, whose area and perimeter are numerically equal. So we are talking about kind of rectangle. Okay. It says numerically equal means we are now talking about the units, right? Let's say its length is L, width is W, right? And here, L and W, these are integers. And more than integers, they are positive integers. That means that what we mean by positive integers, it is 1, 2, 3, 4, dot, dot, dot. These are positive integers, right? So numerically equal means perimeter is equal to 2 times length plus width, right? And that is centimeters. And how about the area? It is length times width centimeters squared, or if it is unit squared. So we are just, if we are ignoring this, right? And here we are claiming that if 2 times L plus W is equal to L times W, right? So find the dimensions of all the rectangles. What kind of rectangles are they? So that the numerical value of perimeter is equal to numerical value of the area. Guys, would you like to try this? For example, what number satisfies this equation?
Should we guess or do by equation?
Let's say again.
Should we do by guessing or do by equation?
I don't know. What do you think? How can we do that?
I think usually it has to be by equation.
Well, equation, how can you form an equation here?
Like take W to, no, it should not. Actually, take the W to there and expand that bracket. It becomes 2L plus 2Y divided by Y. Then it becomes 2L divided by W plus 2 is
Okay.
equal to L. Then
So
take L
you're
to,
very good. You're saying that here, let's say this L, here we have 2 times L plus W, and divide both sides by W, which is equal to, here we have 2 times L over W plus W over W is equal to 1, right? So that means that what does it mean? Here we have 2 times L over W plus 1. On the left hand side, we have L. That is a positive integer. On the right hand side, also it must be integer. What does it mean? It means that from this, right, from this, number one is, the first case is, what is it? If W is equal to 2, right? What we have here, if W equals 2, then here we have L will be equal to 2 times L over 2 plus 1, which is equal to L plus 2, right? So if it is 2, is it correct? This L cancels each other, so we don't have any solution here. So W is not equal to 2, right? Okay, the second one is when L over W is an integer, so that means that this L over W should be equal to some K, right? So from here, that L is equal to K times W. So now if I substitute there, what we have here, L is equal to, okay, not L. What is L? It is K times W. So here we
just
have
count
K
out fine.
W. So here we have 2 times, what is L over W? That's equal to K. Is it?
What?
Now here, if L equals K times W, all right. On the left hand side, we have L, that's equal to K times W, or just L. On the right hand side, we have 2 times, what is L over W? L over W is K. Here we have K plus 1, right? Is that correct? So here, what are K? K can be anything. Find the dimensions of all the rectangles with integral size, whose area and perimeter are numerically equal. Okay, so it should
Teacher,
be like this. If K
I
equals,
found
huh?
I found that width equals 2 plus 2 over length.
Okay. No, I mean here, 2 times K plus 1, right? That's L. And what is W? W is 2, W is L over K. Okay.
In here, you can just find just find the ratio because there is 2 unknown and 1 equation.
Okay, that's like this, right? Because here, anyway, let's just start from here. So L equals 2 times L plus W over W, right? And after, if you simplify this, here in the expression, we have L over W. When L over W is integer, this L must be a multiple of W. And suppose that L is equal to K times W. If you substitute into the equation, so here we have 2 times K plus 1, right? And from here, if L equals 2 times K plus 1, substitute there, then W will be equal to 2 times K plus 1 over K, which is equal to 2 plus 2 over K. And again, when actually that thing is, what is this? Integer, when K is equal to 1, K is equal to 1. And 1K is equal to 2, right? We have only 2 possible answers. If K is equal to 1, if K is equal to 1, what is length? Length is equal to 4. And how about width? Width is equal to, if it is 1, that's equal to also 4, right? And how about if K equals 2? If K equals 2, length is equal to 6, and the width is equal to, it is 1, is equal to 3. So here, 4 plus 4, 8, 2 times 8, 16, 4 times 4, that is 16. And here, 6 plus 3 is equal to 9, 2 times 9, 18, and 6 times 3 is equal to 18. And I think that's the only answer. Is that right?
Yes. Teacher, but I found another thing.
Which one?
Instead of giving the value of K, I found that from the step like LW, can I read with 1 second with the, what is
Yeah. But
anonym?
what is the answer? Do you have any other solution?
My solution is width equals 2 plus 2 over length, not K.
No, okay, but what is your answer? Did you get any answer?
Yes.
Did you
A
get any
lot.
answer different from these two?
Yes.
What is it?
Because my equation is different from yours.
No, okay, but we need to find, right, exact solution here. Find the dimensions of all the rectangles. No, we have to show, because I think only these two satisfy this equation. But do you have any different answer?
But I didn't introduce K, because if you introduce K, the equation become a little bit different.
Then Arad, okay, after you form the equation, did you solve it and get the answer?
Yes, there's a lot of answers.
A lot? Just tell me one answer, different from these answers.
Okay, 1 second, I find something.
What is it?
1 second.
1 second, 1.
No, I mean 1 minute.
1 minute is too much. Arad, I think there's no solution. Because here, all right, this 2 plus 2 over K, when it is integer, when K is the factors of 2. How many factors does 2 have? Only 2, 1 and 2. It doesn't have any other factors. Otherwise, it will not be integer. That's why we have only 2 possible answers. One is the rectangle whose length is 4, width is 4. That's a square. And square is also a special rectangle. The second one is length equals 6 and width is equal to 3. 6 times 3, 18. And if you find the perimeter, 6 plus 3 is 9. 2 times 9 is 18 again. Okay, all right. You just keep doing this. If you have any different answer, you will get back to this question again. Another question, I think we already did this, but let's just do this again. Okay, guys, 2 questions, and after that I will finish. A whole number is between 40 and 70. When it is divided by 3, the remainder is 1. And when it is divided by 7, the remainder is 2. Find the number. Okay, this one is not the general method, but just since we are talking about the number between 40 and 70, I'm just going to use this method. Also, that is one good method in math. That is
I think
guess
it's
and the trial method. Yes,
I
Arad,
think it's a 58.
huh?
58.
58.
Yes.
Okay, that's 58. When you divide by 3, the remainder is 1. So that is 3 times 19 plus 1. When you divide by 7, 58, it is 7 times 8, that's plus 2. Okay, dot, dot, dot. The answer is 58. Another question, find the value of this. Okay, here we have 2 over 2 plus 12 times 2 over 2 plus 12 times 2 over 2 plus 12 times blah, blah, blah. So again, that's actually now you get the idea how to solve this, right? We have a kind of pattern here. And let's
2
say
over
the whole
5.
thing is equal to capital A, right? At the time, still starting from 2, right? Now here we will have 2 over 2 plus 12 times. Now, actually, that is the same with the original one, right? Starting with 2. So that's equal to capital A. Now here I have capital A. So now it's just we get a quadratic equation. Here we have 12a squared plus 2a, and take 2 to the right hand side. That is minus 2 is equal to 0. Or if you just divide both sides by 2, here we have 6a squared plus a minus 1 is equal to 0. Now let's solve this by factorization. 6a squared, we can write it as 3a and the 2a. How about this negative 1? It is plus 1, so here we have negative 1 times 1. If we cross multiply, 3a minus 2a is equal to a, so we can factorize it as 3a minus 1 times 2a plus 1. That's equal to 0. Now, if you solve this, that capital A equals 1 over 3, or that capital A is equal to negative 1 over 2. Now, as I say here, 2 over 2 plus 12 times 2 over something, it's all positive. So that thing cannot be equal to negative number. So this answer is rejected, right? So dot, 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 that fraction is equal to 1 over 3. All right, another question, find the value of this. 1 over 2014 plus 3 over 2014 plus 5 over 2014 and blah, 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 2013 over 2014. But here we have the sum of the, what is it, odd numbers. And since, let me just denote this by S, right? And S is equal to 2014 is a common denominator. I can just keep it here. Here we have 1 over 2014. And here we have 1 plus 3 plus 5 plus dot dot plus 2013, right? So now if you just write a bit more terms before 2013, what we have here, let me just write here. We have 2009 and plus 2011 plus 2013. Number one, what method I'm going to use here? First, I should find how many numbers do we have here, right? How many numbers? This 2013, I can write it as 2 times 1006 plus 1, right? So that means that if you multiply 1, for example, let's say the general term is something like this, right? 2 times n minus 1. Okay, let me just write this one as 1007 minus 1. right? If n equals 1, 2 times 1 minus 1, we get the first term, it is 1. If n equals 2, 2 times 2 minus 1, 3, we get the second term. If n equals 3, 2 times 3 minus 1, we get 5, that's the third term. If n equals 1007, right? And we get the last term, that is 2013. That means that here, how many numbers do we have? Here we have 1007 numbers. Very good. So that's equal to 1 over 2014. Now, if we just pair the numbers, the first one and the last one, what is it? Here we have 1 plus 2013, right? And how about the second one and the second from the last? That is 3 plus 2011. And how about 5 plus 2009? Here we have 5 plus 2009. As you see here, all of these sum are 2014. That's equal to 2014. That's equal to 2014. And how many 2014s do we have? We have 1007 2014. So the whole thing is equal to times 1007. We have 2014. So now the things cancel out each other. So the answer is 1007. Yes, Arad.
Teacher, but like if you see when you're adding, it's even number. It mean like two when there be two in there. It mean but when you have three like 1, 3, and 5, when you add them, two of them goes, but the middle one still is there. It mean 1006 times 2014 plus the middle number.
Okay. I got it. All right. Thank you very much. Thank you very much. That's very important point. Okay. What Arad is saying that here we do not have even number of terms. Here we have odd number of terms, right? So if we just join them, what we have here, that's equal to 1 over 2014 times, let me just write here. So if you just pair this, so here we have 1007 numbers, is it? If we just pair them, here 1007, we can write it as 2 times 503 plus 1, right? 2 times 503, 1006 plus 1. So actually here we have 503 2014, right? So here we have 503 times 2014. But in the middle, what we have here in the middle? In the middle, we have 2013 plus 1 over 2. 2014, is it 1007?
Yes.
It's 1007, right? So that is plus 1007. Now, if we simplify this, why this 2014 they gone? So here we have 503 plus 1007 over 2014. So which is equal to 503 plus 1 over 2. That's equal to 503 and 1 over 2. Yes, Arad, as you see here, the tricky question, actually we should pay attention to this. Very good. Thank you very much. The last question, I think, okay, we have more questions. Guys, let me stop here, okay? Maybe when you have fresh mind, actually, in the morning, I don't know, sometimes you should try, and it really helps you a lot, improves your thinking skill. And these are challenging and not so hard, but also not so easy. As you see here, if you just miss 1 point, you get wrong answer, okay? So I think I already shared this paper with you, okay? And also next time we are going to practice some more questions, and next Friday you will have tests, and after that we will start new chapter, and the next 3 weeks we will study trigonometry. Guys, thank you very much. If you have any question, you can just drop in WhatsApp, okay? We can discuss through there. Now I'm going to end this meeting. I will see you next Tuesday. Have a nice weekend. Bye.
Bye.
Bye. Thank
Bye.
you. Bye.
Bye.
Bye. Thank you.